Hi, everyone. Welcome. My name is Eileen Huster. I'm part of the BeMoved Media team. And today we have here with us Nicola Tomati, CEO of BlueBotics, and Matt Wade, VP Marketing of BlueBotics. And they will be talking about the future of AGVs. We're very happy to have you. Please take it away. And questions you can add on the panel at the right, and we will be reading them at the end of the session. Please write your questions in there. Thank you very much. Go ahead, gentlemen.
Thank you very much for the introduction. So I'm the one starting to talk here. So you already presented both of us. No need to take more time on that. So what we'll be talking today, first of all, very quickly, who we are. We are a company of robotics, so our vision is to be the reference in autonomous navigation, and our mission is to help companies meet the challenge of vehicle automation. Basically, we help indeed vehicle makers to automate their vehicle, and our goal is to put one of these blue boxes into the vehicle. If you look the pictures here, these are all vehicles that have been automated by our customers, and we go from small vehicles moving 100 kilograms up to vehicle moving 100 tons, and also every possible type of vehicles. That was just about robotics. Now let's enter into the real part of the presentation. So today I will first start by talking about a few market trends. There are some, let's say, hype discussions out there, and I think it's good to have some exchanges about these ideas. And then Matt will take over about market opportunities, what's happening in the market and what are the trends and how to position with respect to these opportunities. So I start then with the obstacle avoidance. You may be aware that there is a lot of discussion about vehicle that should automatically avoid obstacles. That's quite interesting because this even created a new definition in these automated vehicles. Today we speak about autonomous mobile robots, and if you look to the official definition of this AMR, which has been even standardized in North America, we are basically talking about vehicles that can avoid obstacles instead of just stopping in front of an obstacle. By the way, this is exactly what, let's say, a regular automated guided vehicle does, which is indeed they move on a predefined or pre-planned route. And if something is on the floor, well, they just simply stop. The funny thing about this is that today, if you read articles, you look at the website, etc., these suppliers, these AMR suppliers, they try to convince us that it's much better to do this than to do this. Of course, what we are showing here is a bit exaggerated, but it's a good introduction for this first topic. So the title of this section is Obstacle Avoidance is not the solution. In reality, of course, this is not an absolute conclusion. One has to be careful about what we are talking about. Here we see an example. You should see an example. Here we go. Sorry, it was a bit bumpy. We see an example of a cleaning machine. Cleaning machine is not a machine like another vehicle that just has to go from point A to point B in the fastest way. It's a cleaning machine. It's a machine that has to go everywhere in order to clean the floor. So that's a good example where obstacle avoidance makes sense, because if you have to cover the whole floor, you most likely encounter some obstacles, and it would not be very neither effective nor efficient to just stop and wait for an operator to come solve the problem. So that's a very good example where obstacle avoidance makes sense. A second example where obstacle avoidance makes sense is this example here, where you see a guide robot in an airport, the Geneva airport. So this is an environment which is designed for humans and is crowded with humans. So there it's very difficult to plan a place where you can really optimize the route of the vehicle, the path of the vehicle, and make sure they can go at full speed. So that's another example where indeed obstacle avoidance is the solution. So again, why is obstacle avoidance the solution? Well, to summarize and try to generalize, if the vehicle has to move everywhere, like a cleaning machine, a guide robot is very similar, then it makes sense to avoid obstacles. It makes sense to avoid obstacles in an automatic way if the environment is very crowded. Let's think about museums, airports, etc. It makes sense, and that's a tricky one, if there is enough space and not too much traffic in the sense of traffic of the vehicles themselves. In this way, if you have enough space and not too much traffic, you have indeed many options. You can try to move right and left to find a new solution. If you do not have enough space, of course, you cannot move right or left, and there are no questions. And if there is a lot of traffic, that's a tricky one. You need coordination. And coordination speaks again, having a single machine that decides to do whatever they want. Another important point, this obstacle avoidance that is sold today as being the absolute solution, in reality only works well if you have a vehicle that has a size and a kinematics which is compatible. So basically, if you have a kind of rather compact vehicle, for example, with differential drive, more or less random, which means that it can kind of turn on the spot, then this kind of maneuverability allows to have a good avoidance of obstacles by moving around them. If you think, on the contrary, about a huge vehicle of 10 meters, 20 tons, very long, even a human would have troubles in driving this vehicle around obstacles. So really, again, obstacle avoidance is a solution if the vehicle makes sense in terms of size and kinematics. Here we have some other examples. So that's a typical material handling application, and it's a good question if this machine should or not avoid obstacles. We have some experience thanks to our customers, and we think that one should not try to do obstacle avoidance if you're seeking efficiency. The reason is quite simple. There are in reality two reasons for that. The first one is that if you are a vehicle supplier and you go to your customers saying, we have a very smart solution, we can provide obstacle avoidance so that you don't have to care about what you leave on the floor, well, the result will be that people will not care about what they leave on the floor. And this means that even if the technological solution is perfect, the fact that you have to move around obstacles will make the time needed to move from A to B longer. So you are losing efficiency. So if you need high efficiency, you'll better define an obstacle as an exception and plan for a free path that allows to go at full speed and so to maximize efficiency. If you have a large fleet, this is what I was introducing already before, you need coordination, what is called traffic management. Those that sell the concept of AMR, they try to convince us that if you have a traffic jam in New York, it's better to tell all the drivers that they should not respect anymore any traffic rule because they are smart, and then things will be better. This is not true. If you have traffic jam, of course, it's not ideal, but it is exactly when you have traffic jam that you have to optimize the traffic rules to have the best result. If you just let everyone randomly think that they're intelligent, this will just create chaos. It will not create a better performance. This I said before, large vehicles, not only they are difficult to control, but even it would be difficult to accept for the operators and the other people that will be working around vehicle, that a 20 tons vehicle starts to do kind of random slalom if there is an obstacle on the floor. If you have a big vehicle, as a user, you prefer to exactly know where it is supposed to move so that you feel better in terms of perceived risk. Even, of course, if the risk is not there, because all these vehicles are very clearly safe, they have safety regulations, certification, etc. It's more a question of perception. The space could seem as a joke, this one, but is in reality one of the most important points. Today, we as technology supplier, we are approached by new potential customers that want to automate the vehicle. And very often they tell us, oh, I need to have obstacle avoidance. By the way, we have it, but that's not the topic. The first question we ask them when they say we need obstacle avoidance is, why do you need obstacle avoidance? It's very important for us to understand why someone, what is the use case, the need behind that. And the answer is most of the time because the customer is asking for it. So the second question is always, fine, do the customer have space to move around obstacles if there is an obstacle? And I would say that in 95% of the cases, the answer is no. They just write, oh, no, that's not possible. They do not have the space. So, and the reason is very simple. Space equal cost. So if you do a plant, a warehouse, a production line, you will not just inject a lot of space because maybe you have to move around objects. You will optimize the space. And so most of the time, you do not have space to avoid obstacles, and you better make sure that the small space which is planned for the vehicles is free. So based on that, in our experience and the experience of our customers, really the message is, do not use obstacle avoidance for production. And even for warehousing is extremely difficult. I think for warehousing, it could be used as exception for special cases, but again, as a generic solution, this would result in a lower performance, lower efficiency. And talking about efficiency, we have an interesting example, which is an example for tire production in North America. There, they had 37 vehicles using obstacle avoidance, another technology, not ours. So since this customer decided to use our technology, and they're still working today with our technology, they told us, we want to use your system, but we must have obstacle avoidance. By the way, I'm going back here. These vehicles are differential drive and quite rounded, so obstacle avoidance would, from a technology point of view, work well. So it would be able to move around obstacles. But we really told them, please, 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 try to test without obstacle avoidance, because we don't think your process needs obstacle avoidance. Fortunately, that's what they did. And they have so retrofitted 30 of the vehicles they had without the obstacle avoidance using our technology. And the result of that is that they had 10% more delivery with 30 vehicles compared to the 37, which is representing a total performance increase of 27%. So that's just one example to illustrate obstacle avoidance as a big risk of reducing efficiency. Again, of course, if you have questions, please drop your questions in the chat so that we can talk about this in the end. Second point, there is a lot of hype. Now it's getting better, but I would say still it is, and it was even more a few years ago, about cloud computing. So we should put everything on the cloud. We should use distributed intelligence. We should do Internet of Things, IoTs, swarm robotics, swarm intelligence, all these kind of interesting keywords, which are interesting, but one has to be careful about what happens then when you go out in the real world. And this is just to illustrate, this is an example of Wi-Fi coverage in an office space. And it's just to illustrate that the red one has good coverage, and then it goes lower and lower, and there are places where you have almost no coverage. What does this mean? Well, it means that one has to be very careful about how you transfer data if you want to automate vehicle. There is a fundamental difference between a PC, a computer, a laptop, and an automated vehicle. The automated vehicle has to move almost everywhere. And with the laptop, if you go to a place where you see, well, there I have no contact, where either you move yourself or you put the cable, well, the vehicle, you cannot put the cable, and it has really to go to the place we are telling him to go. So in these terms, there is a lot of risk that you go to places where you do not have a good coverage. And that's why you should be careful about how you design the system. By the way, the first time we discussed about this topic, we had some questions from from the people that were listening to the presentation. And later on, we could find this interesting graph, which is showing the cost change between 1992 and 2015 in terms of computing power. Again, I tried to make it simple. The computing power cost has dropped 7,400 times. The data storage cost has dropped 28,000 times, and the cost of 1 megabyte per 1,000 megabyte per second dropped only 100 times. So those people that tell us, yeah, you should do everything cloud, everything distributed, etc., and today does not work, but it will be solved with 5G. Well, be careful. The infrastructure cost that was put in for 5G will again make sure that the cost of network will not drop dramatically. So you really have to have good reasons if you want to distribute everything everywhere. And that's why when we think in terms of what we should do in order to face this reality, we say that given that a vehicle has to move everywhere, you should really have the technology, especially the embedded technology, that is as independent as possible from the network infrastructure. You should minimize the critical communication and the amount of data in general. And you should implement a solution that is fail-safe. There are solutions even for safety today that are Wi-Fi, and that makes sure that if you don't have the contact, everything stops. If you do that, well, you really have to make sure that you have a very good coverage, otherwise your operation will stop very often, let's say for nothing, just for infrastructure problems. So that was about the infrastructure and the hype in distributed IoT, cloud, etc. Now, another comment we have, another trend we see on the market is the change in the role of the integrators. Integrators, we name integrators these companies that take a lot of different technologies to deliver into a system to automate any kind of process at the customer side. So in the past, the integrator was having a different role compared of today. The main reason is that technology is getting simpler, which is good. So in the past, the technology was extremely complex. Now it's getting simpler, but, and that's very important, it is the process that is automated that is becoming more and more complex. That's the main difference. In the past, we were using complex technology to automate simple tasks because it was not possible to do something more. And today we are using, let's say, simpler technology, but to automate rather complex tasks. And that's where the integrator plays a fundamental role. So we, as a company, BlueBotics, are a component supplier, a navigation supplier. I think we are very competent in terms of navigation and how to move vehicles around, but we do not understand the details of semiconductor production. This, what we see here is a semiconductor production here in Switzerland. It was ABB, now as Hitachi does a detail, but basically semiconductor production is one of the most complex production process, and you really need to understand every single detail about this process if you want to make sure that the technology you deliver to a customer really creates value to the customer. So that's just an example. It's quite high tech, semiconductors, etc. But the fact is that even rather simple processes, here we have a production of showers in the north of Italy, and they have automated the delivery of all the components to the production with these AGVs. And the process was extremely complex. They must deliver in a certain ways, last in, LIFO, last in, first out. They have to guarantee that these boxes are getting to the right place on the right moment, on the right order, and they've used for that 11 vehicles. They have a huge return on investment on this, but that was a rather complex implementation of automation for, in reality, a simple product, but a quite complex process. So just to say that really the role of integrators has changed, and not only for the high-tech, but in general. If we want to automate the production of showers, we really need to understand their process. So as I said before, in the past, integrators were those commissioning complex technologies for rather simple processes. And today, this has become the contrary. The technologies are getting simpler, but we want to automate more and more complex processes. So the integrator already in the past was a player, an actor that was very important. I think in the future they will become even more important, because this will be the companies, the people that understand how to create value with the technology. Last point, one of the other big trends in the AGVs, so automatic guided vehicles, or I mean automated forklifts or mobile robots, etc., no matter the definition, is interoperability. That's also quite interesting. There are more and more large organizations that need many different vehicle types, and they need to make those vehicles work together. So let's say that we want to move from what we had until now, which is for every vehicle model, you have a fleet manager that is not able to talk with the other. So it's a very complex setup, to have a single system that can control different vehicles. That's the dream of all the production manager, warehouse managers that today want to automate their operation. Now, how can we make different vehicle types, different vehicle models work together? There are basically three approaches. The third one will not be presented here. It will be Matt talking about it later on. But basically, the easiest way to do that is to implement a kind of rather simple traffic light mechanism, or virtual traffic light, called also interlock. The second one, you may be aware or not, but there are standards that are created right now. So there are initiatives in Europe, probably the most advanced, in North America, in China, in Singapore, there is another one. So there are several standards that are coming right now. And later on, Matt, we will present how we have approached this trend. So let me explain a bit better. Let's say you have two different vehicle types that are operating partially in different places, but they have something in common. So let's say we have the orange vehicles that are working on this orange topology, let's say, or part of the environment, and then you have the blue ones that are working on that one. So here we have this red part here, which is in common. And in order to make this work, you implement on both sides, on both different fleet managers, or let's say self-control software, a kind of traffic light mechanism that is only locking the red part when it is needed. This works. This is rather simple to be implemented. It has the advantage of being simple. It has the disadvantage that it doesn't allow to have a global optimization of the systems. And again, this is a rather simple example, but if you have more complex examples, you may even create a situation where the different vehicles or different setups are blocking each other, what is typically called as a deadlock. But again, if you just want to have basic interoperability, this is doing the job. Now, there are, as I said before, standards that are popping up. And this is good. I think standardization will help guaranteeing more success in the future. The question is, where are we right now with standards? So the European one is, to be honest, more a German one. It's called VDA 5050, which comes from German, Verein Deutsche Automobil, something like this. So it's basically the automotive industry has mandated the German Association of Material Handling to define a standard to make vehicles, AGVs, automated vehicles, interoperable. There, as I said, is driven by the European automotive industry, especially the German one. Then we have in North America the mass robotics approach, which is driven by indeed North America AMR suppliers. So that's already a fundamental difference, because we have the German one focusing on, let's say, more classical AGVs, those that really deliver value, that focus on efficiency, on delivering, on production, etc. While in North America, it's clearly focusing on AMRs, so autonomous mobile robots doing obstacle avoidance, etc. We are at version 2. Version 3 should come soon for VDA 5050, and for MAS we are at version 1. The point is that both of those standards and the others are more or less at the same level. They are not yet finished. So basically what they can do with VDA 5050 is doing some demos. Well, this was the demo 1 year ago, to be honest, where you had 4 different brands just moving around and crossing each other, but they were not even able to pick up payloads because this was not yet defined in the standard. And the mass challenge, the more advanced part that we saw is a video on the web showing 2 different vehicles that use the same charger. So the goal is absolutely correct. It's good to go towards standards, but it's a long journey. So even VDA 5050, so the VDA makers that are working on the standard, and we are part of it, they expect still at least 2-3 years before we have a completely usable standard. Be careful. Already today you will find many suppliers that say they are VDA 5050 compliant. It's true in the sense that the standard covers maybe 50-60% of what is needed, and they comply to this 50-60%, but it means also that the 40-50% remaining is kind of custom specific, and it will not be compatible with the future. And on the other side, we are really just at the beginning. To be honest, we should update this part of the presentation, because I think the one developed in Singapore is more advanced than the one in North America, but with the same problems. And by the way, it's interesting because not only the standard is not yet complete, but there are some practical questions that can be raised about this interoperability approach with the standard. Basically, the idea is to say, we use a standard, so you as an end customer can buy an AGV, or let's say AGVs of type A from supplier A, AGVs of type B from supplier B, and then you buy the fleet management system, so the coordination software for this vehicle from supplier C. Since we have a standard, all these vehicles and systems should be able to talk together. There are, however, a few questions. So, okay, now as an end customer, I have 3 suppliers. And the question is, who will be commissioning the AGVs of supplier A and B? Is that supplier A delivering and someone else is doing the commissioning? Or is that supplier A coming and doing the commissioning? Same for B. Which tool is used, or which software tool is used to program what vehicle type A and B have to do? Is that the software from supplier C, because it will be the fleet manager later on? So will we use this kind of software to program a vehicle type A and B, or we have to use 2 or 3 different tools to do the job? How to make sure that all this software, they take into account the different characteristics of the vehicle type A and B. Let's say one vehicle A is a fork that can move 2 tons and can go up 4 meters, and vehicle B as a fork that can go up just 1 meter and move 5 tons. Is that fleet management system C that they have to take this into account, or is that, how is it done in general? There is some work that is coming, but it's not clear how to define that in the old system. Then there are other practical questions for the operation. Let's say now, okay, interior is installed, but who will guarantee that vehicle A and vehicle B will be able to go to the exact same position? Because very likely these 2 different vehicles, they will use different technologies. So they will, how to make sure that their localization, their way of measure where they are, is exactly the same in the space. And who will be in charge of that? If they are not doing this job, do you call supplier A, supplier B, or you ask supplier C to solve the problem? Same thing if you have 2 vehicles that are blocked in a crossing and you don't know what's going on. So you, as an end customer, will you call supplier C saying, hey, your fleet management system is not able to handle two vehicles in the crossing, or will you call supplier A or supplier B? These are all questions that are not clear today, so there are a lot of these kind of questions. And personally, I think that until we clarify this, the standard is even more a danger than a solution, because as an end customer, if I am the end customer, I would like to have one single phone number I can use if there is anything going wrong in my operation. So I was talking quite a lot about all this, so now it's for me the time to give it to Matt, who will be talking more about the market. So VP Marketing is the best person to talk about the market. Thank you very much, Matt. It's your...
Thank you, Nico. Hi, everyone. Thanks for joining us. So let's talk about market opportunities for companies that have and that develop automated vehicles of different types. So if we start at a very global high level, the first big opportunity is the market itself, meaning the market for whether you call them AGVs, AMRs, automated forklifts. This has a track record over the last few years of growing strongly and is predicted to do so. So you're generally seeing something between 15 and 35% annual growth predictions, depending on which market study you're reading. And obviously the geographic region has an impact as well. But what we see is that that's not pure prediction. This has been the track record over the past few years. However, the market today is still very much an embryonic new market. It's still very fragmented. It's still very crowded. You can see just the automated vehicle producers there in the graphic on the right, an enormous amount. And for sure, there will be more consolidation. There has been quite a lot already, but that will continue. Indeed, BlueBotics has been part of that in one sense, which I'll talk about afterwards. But the key question then, whether you're investing in the vehicles to use in your production plant or whether you're looking to develop those vehicles yourself, the risk or the question is, how do you find a partner that will still be there in 5, 10 years? That's really a key question that anyone with any intention of using or developing AGVs needs to look at. Thanks, Nico. Now, in terms of which applications and which industries are really driving this growth, if we dig into that a little more, maybe start with a little history. So in the beginning, almost all the AGVs in use were really used in manufacturing. And for example, automotive was a big driver of that. But then in recent years, that trend or that weighting has been disrupted a lot by the e-commerce revolution. So we're talking about smaller robots like Kiva, which is now Amazon Robotics, being used in fulfillment centers, most of these, new builds, greenfield sites. And we're talking about smaller, cheaper mobile robots being used in very large numbers. And that's really skewed the numbers in the direction of warehousing in recent times. It's worth noting that the axis on the left there is talking about units. So units of mobile robots, numbers. It's not talking about the value, the overall value of that technology. If it were, manufacturing would have been higher income, higher than it is, because the systems used in manufacturing, the AGVs, are generally speaking, a higher investment than a small AMR for e-commerce. What we see looking ahead, well, today and looking ahead, is we see that manufacturing is catching up and will continue to catch up. And I think what we see the reason for that really is that we're slowly going to be moving from those initial boom years of e-commerce with large greenfield site fulfillment centers packed with small robots to much more the more gradual automation of more manufacturing sites, and most of those being brownfield manufacturing sites, existing sites. Now, they are, as you might imagine, a more complex challenge in terms of installing AGVs, and therefore they've needed a higher level of technology to make that type of automation work, and for the tech to have the flexibility you need to work in those kind of sites, which is why that's coming more and more now. It's also interesting to look at where the opportunity presented by where the vehicles are used. So obviously, fulfillment centers in manufacturing plants, the vast majority of that usage is indoors and has been up to now. but we do see a trend of more AGV usage outdoors. Again, I'll point out that we're talking about units on the left, numbers of vehicles, not value. If it were value, this red chart signifying outdoor use would be higher, since usually we're talking about larger vehicles or more expensive vehicles being used outdoors. So take a heavy transporter AGV or a shuttle AGV that's running between buildings. These could easily run into hundreds of thousands of dollars. So that would make it a very quite a different chart. But we definitely see this trend, and this definitely fits with our experience at BlueBotics working with producers of AGVs. That's a trend that in particular select ones of those with that leaning towards outdoor are really benefiting from that. And if we talk about what does that mean, the outdoor kind of opportunity, if you like, the key two use cases are really those on the top left there. We're talking about moving payloads between buildings. Now, they could be production buildings or they could be plant and warehouse within the same site. And more generally, just linking logistics and production. So I'll give you the example in the bottom right image there of moving in Spain 25-ton steel coils between production buildings, between stages of production. Another example in the middle at the bottom there being moving at a Michelin plant in Italy, moving tires between production and warehouse. But these type of applications really cover a huge range of markets potentially. You've got the body of a plane there in aerospace. We see airports. We had a client recently with an ongoing test at Barcelona airport, moving cargo and luggage from the I think it's called the curtain, the tarmac, through to a warehouse. And these kind of applications are really ripe for automation. What I will add is that this has led us to work more on this as well. And if you follow it all BlueBotics, you should see us announcing a new product extension that really speaks to this type of application in the coming weeks, which should make that type of outdoor usage even more precise and even easier. Now, Nico talked about interoperability before and the different ways this can be achieved. This is for sure a strong opportunity we see in the market. It's very much a growing question from end users, particularly large multinational end users who are looking to standardize around the automation platform that's running all their vehicles. So this is a clear need as the market develops. And here what we can show, Nico talked about the different ways, interlocks and the standards. And as far as our approach at BlueBotics today, what we have is that of the different vehicles that are run on our ANT navigation technology, is something like 110, 112 models today. Somewhere around 70% of those have the version of ANT inside that can render them interoperable, meaning irrespective of the brand, they can be running the same fleet on our fleet manager software, which is called ANT Server. So if we flick to the next slide, there's just a video example there, and we can really talk about and see what does interoperability mean. So this video will show us kind of a good example of that. It's something we put together here in our test lab, but we can see that we have many different types of AGV and AMR, and even you see there the cleaning robot that can run on the one software. Now, today, these need to run on ANT, but as Nico mentioned, there are standards coming, and we are in parallel working on VDA 5050, for example, as that evolves. So here you can see an AMR robot, so the BlueBotics mini platform that we make available to our vehicle maker partners, which, like Nico mentioned at the beginning, can run on, let's say, path following or that obstacle avoidance kind of behavior. And in the same video, you can see at the bottom left there, the fleet manager, ANT server, and the web interface of that shows the vehicles in operation, which is useful from an end user perspective, but also for testing when installing these kind of vehicles. The goal really is make the different machines and platforms work together. And why is that important? Well, just take the use case of you maybe want to move pallets from warehouse to production or to assembly. You might, in the first instance, start automating those simple processes with automated pallet trucks or forked AGVs, basically. But that might not be the beginning and end of your kind of mobile automation. In future, you might want to look at different processes. And it's quite possible that the vehicle maker, the AGV supplier that you work with, simply doesn't offer those models yet. There are very few AGV suppliers offer a whole huge range and portfolio of systems. And as Nico alluded to before, it's obviously potentially a nightmare scenario if you then buy in another brand and have to use a different fleet manager and have different spaces allotted for different virtual routes around your site. As Nico mentioned, lots of sites, especially brownfield manufacturing, there isn't that space available. So the idea that you could work with the primary integrator, but then you or they could bring in additional vehicles that can run on that same software, that's really the goal. That makes the operation more efficient, keeps costs sane, and also reduces complexity. So I would say if we just flick to the last slide, with that in mind, you can kind of see some more examples of that just on our little promo slide here for a site we put together called antdriven.com. So on this site, that really shows in the vehicle finder section, it really shows the types of vehicles that can work together with, let's say, our version of interoperability on the Ant ecosystem. And it's a site we built more generally to really explain that functionality and to try and support the growth of the AGV market that we talked about at the beginning, and to support our customers in that growth. So I think that is it from me. Those are the main opportunities I want to flag up. That's what we see every day from working with vehicle OEMs around the world. And I think that's a good point for us to flip over. If anyone has questions, we'll be happy to try and answer those. And again, thank you for your time.
Thank you, Matt and Nicola. There are a few questions here. I'll start with the first one. How can the BlueBotics system be so efficient to be able to convince a customer to retrofit with ANT almost the whole fleet? The example here is 30 units case of North American tire manufacturer. Is it thanks to a large experience in customers advisory?
Oh, well, I think that the way we approach the market is by the key point that we bring to the market, the starting point is really that our technology makes the AGV easier. So easier, what does it mean? It means that it's easier to automate, it's easier to integrate, it's easier to do the commissioning, and it's easier to maintain. That's really the key point that we brought to the market in the beginning. Then, of course, we are on the market since more than 20 years. We had time to invest, to learn, and to try to answer to the needs of the customers in terms of functionality. So indeed, I think that today is the performance and the efficiency that we bring to the different use cases of the customers that convince our customers to work with us.
I would just add to that it's not necessarily always just a question of sitting in a conference room and convincing. In terms of project planning with our Ant software, there's a strong simulation tool in there. So it's possible we're in the project planning stage to really simulate different operations and different types of usage to see how efficient that is and to make that kind of comparison. So that kind of pre-planning, pre-testing of a project and understanding how that's going to work with the software, that's a really powerful.
And something that, sorry that I'm jumping again, but something that I forgot to say is that in reality, also one of the reasons that convince vehicle makers working with us is the service that we provide. We are really working hand in hand with the customer from the day we start working with them till the day they go to market with the first system that is in operation. It's really a full included service that is delivered as a package, so that the customer that decides to go to market with an automated vehicle, including our technology, has everything under control, and they know that we will work together until it works and until it is a success in the market.
Great. Another question is, while the market CAGR looks good, can you tell us about how the fleet size at end customers are predicted to grow? Will it still continue to be in the area of 1 to 30 AGVs ARMs per installation?
So Matt says I have to start. It's a good question. I think it's really depending on the market. Huh? The statistic I saw a few years ago were showing that more than 80% of the market is in the systems that are between 1 and 5 vehicles. But I tend to agree that there is a trend here too. There is more and more automation, as I said before, of complex processes and larger processes. So I would expect the fleet size to grow. And today is also what we are having here at BlueBotics. We see customers that are automating systems with 100 or more vehicles. And we have right now our customer have discussions for installation of 300 plus vehicles in a single site.
Yeah, I think that fits with what I was going to say, which is that we've done some market research recently, which we'll publish in the next 3 months with existing AGV users through a media partner. We did a survey, and for those kind of companies that are small or medium-sized companies on a single site, like Nico says, I think that they're very much looking between 1 and 5 AGVs, and then potentially adding about the same number within around 3 or 5 years. But for the larger companies that may be at times slower to start the automation process, but then they're looking at projects across sites that can be much higher in number.
Great, thank you. One last question is, will you be able to share these slides on the portal after the session?
We are happy to. I don't know how it is organized, but I think it's planned, no? Maybe you should answer that.
If you share the presentation with us, we can upload it to the portal, definitely.
Then we will, sure.
Great, excellent. I think we are wrapping up then on the end of the session. So thank you very much, Matt and Nicola, for being with us today. And if anybody wants to reach out to you, if they have questions, what's the best way to reach you?
Oh, well, there is the tool within the, I don't know how you call it here, the interface that allows to reach us. Otherwise, you can reach us per email, telephone, website, we accept all kinds of contacts. If you want to buy blue boxes, contact us no matter how.
Great. Thank you very much for being here today. And thank you to all the attendees for watching. Please go to the lobby to watch the rest of the sessions of the day. Thanks, everyone.
Thank you.
Bye-bye.